Good day everyone, I'm Helmi, lecturer of the course Drilling and Drilling Fluid Engineering at ITS Training Center. The topic of this lecture is how to calculate drilling mud lag time and wellbore wall washout. Before we go ahead in the topic, I would like to introduce a brief CV. I have BSc Geochemistry from Alex University, then MSc Analytical Chemistry from South Dakota State University, then PhD in Petroleum Geochemistry from Alexandria University. We begin with what is lag time? What's meant by lag time? Definition of lag time. Lag time is the time that the drilling mud takes in moving from between two different points in depth. For example, here in this drawing, we'll see that this is a surface, zero depth. The time that the mud takes between any two points throughout this depth, you can call it lag time. Why we have to calculate lag time during drilling oil or gas well? The geologist needs to know the exact time and consequently the exact depth from which the cuttings came from. Because as we see, we can have washout from the walls of the wellbore during the open hole drilling. We can have part of the wall in certain rocks, in certain formations. The rocks leave the walls and get mixed with the mud. So in this case, the time that the mud takes from inside, in its move from inside the drill pipe until it reaches the bit, then out of the bit to the surface, this time should be different in case of washout. Consequently, the cuttings will not be ascertained to correct the depth. That's why we have to calculate the lag time. Actually, I will not concentrate on time as the unit which we would calculate the lag with. Instead, I will concentrate on using the pump stock. We know that the mud, the drilling mud, comes from the active bit to the drilling to the mud pump, to the standpipe, swivel, Kelly, and then drill pipe. Okay. This pump should be reciprocating. It helps us in calculating how many barrels of mud inside the drill pipe, how many barrels of mud in the annulus. So let's start with the calculation of the time in strokes, not in minutes. The time in strokes that the mud will take from the surface to the bit, and then from the bit to or the bottom of the wellbore to the surface. The time from the surface, the mud takes from the surface to the bed is called lag L. The time that the mud takes, and as long as we are drilling, it will be mud plus cuttings from the bed to the surface is called lag L. This will be calculated in strokes, and we'll see how. First of all, we should calculate the annular volume. Annular volume is the volume between the outer diameter of the drill pipe and the inner wall of the well bore. How to calculate this? Very simple. Annular volume in barrels equals ID, internal diameter squared, minus OD, outer diameter squared, in inches, divided by conversion factor, and we'll see how we get this conversion factor, times L in feet. So this in inch, and it will be in inch squared, and this feet, and this is the conversion factor that will convert inch squared and feet to barrels. Okay, what's L? L is the distance. Say this is the total depth, TD. So this will be, L will be the total distance that the mud will travel from surface to the bed or from the bed to the surface. So this is L and feet, which is the total depth. Okay. Now we will calculate. We got the mud volume inside the annulus. We call it annular volume in barrel from this simple equation. Second equation, we will calculate the theoretical lag up. Theoretical lag up. Why theoretical? Because we will see how we will have actual lag up in strokes. So this is theoretical in strokes as TK. Symbol. It is equal to the annular volume, which we have just calculated here. Annular volume. In barrels, divided by pump output. Pump output. Units, barrel, per STK, per stroke. This is from the pump sheet, from the pump data sheet. You can get it from the rig. Pump output. Barrels per stroke. Now we'll have this cancel, barrel cancel with this, and this stroke will be theoretical layout and strokes. Say this is equation number 1. Third step. So this was the first calculation, second calculation. Third calculation, we'll divide this volume, drill pipe, and color, in barrel by the pump output from the data sheet in barrel bare stroke. Same like the theoretical leg up, this barrel will cancel with this barrel, and we will have strokes. The leg up, the leg in strokes. Now this question will be number 2. So as you see, leg up was calculated, leg in was calculated, in strokes. First step, calculate the volume, then divide by the pump output. Again, calculate the volume in the pipe, divide by pump output. Again, calculate the volume in the annulus, volume of mud in the annulus, then divide this volume by pump output. Calculate the volume in the drill pipe and drill color, because they have different dimensions, drill pipe and drill color, then divide this volume by pump output. You will get the theoretical leg up and the theoretical leg in. Equation 1 and equation 2. Here we will have assumption that the theoretical leg in is equal to the actual leg in. Why? Why this is different from leg up? This consideration is different from the leg up. With the leg up, you have a communication between the mud and the formation. So either the mud can get into that formation, which case is called loss of circulation, or the formation fluids get into the mud, and this is a kick or a blowout. But we are not in the case of a kick. It's just part of the walls of the wellbore is dissolved. Part of the wall is dissolved into the mud, get mixed with the mud, washout. This is called washout. Not dissolved into the mud, no, and contribute to the volume of the mud. The driller at the rig floor needs to know exactly the extent of this washout. How many barrels of washout are added to the mud? This is the leg up in strokes, and we said that the driller needs to know the extent of the washout, because it means we have hole enlargement. The hole, the wellbore, is not in the same it's the same diameter, having the same diameter. So this leg in and leg up. With the leg up, we calculate the number of leg up in strokes. Leg in, we assume the leg in as the theoretical leg in is as the actual leg in. Why? Because we don't have communication between the mud inside the drill pipe and the formation. This is not the case with leg up, as the mud has communication with the formation. After calculating the theoretical leg up and theoretical leg in, and during connection, calcium carbide is added to the mud at the rig floor. In the same time, the counter of number of strokes of the pump is set to 0. After reconnecting the drill pipe and drilling ahead, the pump starts and the counter of total number of pump strokes starts too. And then when calcium carbide is added, it will react with water and acetylene gas is formed. This acetylene gas moves with the mud until it reaches the shale shaker. In the flow line from the BOP to the shale shaker, there is outlet sampling line that takes the gas. It's coming out with the mud to a gas chromatograph for analysis, and when the acetylene from the calcium carbide is shown in the chromatogram with a peak like this is acetylene gas, C2H2. Alright? Well, they see this, they stop, the mud pluggers stop the pump. When they stop the pump, the counter of total number of strokes, will provide us with the leg in and leg up, the total leg in strokes. This is the actual number of strokes. Equation 1 and equation 2, when you add equation 1 and equation 2, you will have the theoretical value of this number, of this actual number from the counter at the pump. Now, this number we will say this is 3. If we divide 1 from 3, if we divide 2 from 3, this one, if we divide 2 from 3, subtract 2, which is the leg n, from 3, which is the total number, actual total number, we will have the leg up, actual leg up in strokes. And say this is 4. If you have this leg up in strokes as the actual number, you can compare it with 1. Compare 4 with 1. 4 is the difference between the leg in and the total number of strokes in and out. Complete cycle. This is 3. Represents the complete cycle, leg in and leg out. If we subtract leg in from the complete cycle, we will have the leg out as actual number of strokes. We will compare it with the theoretical number of leg up in strokes. If they are equal, there is no washout. There is no wall washout. There is no hole enlargement. If they are not equal, if there is a difference and it's positive difference, this means that we have washout. The number of actual strokes in leg up actual strokes is higher than the theoretical number of that represents leg up. Now time for how the conversion factor equals to 1029, because it's not common, you cannot find it easily in the internet. The conversion factor is derived simply from we'll take the simplest equation here in this derivation. We'll take the drill pipe volume. Drill pipe volume. It equals to drill pipe volume. It equals to ID square of the drill pipe and the drill color. We calculate it in two steps. Using ID of the drill pipe and ID of the color. And as you see, usually the ID of the color is smaller than the ID of the drill pipe. But the color has more thickness, wall thickness, to give weight to the bit, all the bit. Okay, ID squared times L divided by 1029. We will have this explained. 1029 explained. And this is in feet. Okay. This is area. This 1029 and ID square, it has area inside these two, the numerator and denominator. Area equals pi over 4 times inch square. And if we multiply this by how many inch cubes are present in one barrel, we will find 9702 inch cube in one barrel. And if we say to get rid of the feet, we want the drill pipe volume, we want it in barrels. So we will get rid of whatever different than barrel. We will introduce barrel. One barrel equals 9702. Okay, no problem with this. Okay, inch cube. To get rid of the feet of the length, we introduce 1 inch equals 0.08333 feet. 1 inch has 0.08333 feet, and we have the feet from length will cancel out. This inch will cancel out with the cube and make it square, and this square will cancel out with this square. So by the end, we will have 3.14 for pi, 3.14 divided by 4 times 97202 times 0.08333. Then this number will end up with 1 over 1.029. To convert the area, inch squares times feet, inch square times feet, it's volume, but not in barrel. So we introduce the barrel and cancel out the feet by this number, and you will end up with 3.14 divided by this number. If you divide this by this, you will get the 1029. Thank you for your attention, and I hope you can have we can have you in this course very soon. Thank you.